This is Kelly Ann Mahoney. I'm a youth program specialist at Autodesk and super happy to be speaking to all these wonderful art educators and other educators in Illinois. And we also, I knew I was going to mess that up, Natrice. And also just want to, thank the Illinois Art Educators Association for welcoming us here. So again, I work for Autodesk. Autodesk is a software company. We make software for people who make things. But today we're going to be talking about Tinkercad, which is a product that is part of the Autodesk family. I also was a teacher in the Boston Public Schools for 13 years. I taught primarily English, but I also did a lot of technology and arts integration in what I was doing. So I taught graphic design and I taught filmmaking as well, and really hitting upon some of the media literacy standards that are part of the English standards as well. So we will try to talk a little bit about standards today, but not too much because we want to keep this fun and exciting. So I'm going to also introduce Natrice, who I am honored to be co-presenting with. Dr. Natrice Gaskins is an artist in residence at the Autodesk Technology Center where we are. And we also met here as well. So Natrice was a computer science teacher teaching computer science through the lens of art at Boston Arts Academy. So this is Natrice Gaskins.
Hi, I am on board to talk about the A in STEAM and the work I've been doing here at the Technology Center, Autodesk Technology Center, as part of my work with Math Talk, which is a kind of a startup in Cambridge, Massachusetts. And I'll tell you more about that later.
Awesome, thank you, Natrice. All right, so now I'm gonna share my screen. This is Natrice and me, and here's more information to get in touch with us later. So we have some of our social handles. Natrice's website, natricegaskins.com. is really awesome, and you also need to check out her art on Instagram because it's pretty amazing. And I've also just given my personal Twitter handle as well as information to how to connect with Tinkercad and also the Autodesk education community. All right, so the topic today is teaching the A in STEAM with Tinkercad. So I'm just going to quickly talk a little bit about Tinkercad and how you can use Tinkercad in your classroom as a creativity tool to not only teach art, but also to integrate art with other subjects as well. From there, Natrice is going to talk about her Math Talk project as well. So we hope that you enjoy. All right, so just really quickly, if you're not familiar with Tinkercad, Tinkercad is a free, easy to use, browser-based app, which is a creativity tool that you can use with your students so that they can take their ideas that they have in their mind and bring them to design in minutes. So super easy to use and it's free for everyone. I should also note that all of Autodesk software is free for educators and students as well. I am a terrible salesperson, so this is a good gig for me that I don't actually have to sell things. All right, so Tinkercad. So Tinkercad has 3 environments. There's the original 3D design editor, which is the one that probably most people are familiar with if you're familiar with Tinkercad. There also is electronics as well, where you can simulate circuitry. And then there is also our newest environment, which is code blocks. So just really quickly, this is what the original 3D editor looks like. With the original 3D editor, you can just drag and drop shapes really easily, combine them. You can also turn them into holes and subtract from them in order to make more complex shapes that you can then send to actually 3D print as well. Natrice later is actually going to also provide us with a demo of Tinkercad within the context of her project. This is just a little sneak peek at the circuits editor. So in the circuits editor, you can simulate circuits. You can also program an Arduino board as well. So circuits is really fun. And then thirdly, our newest environment is code blocks. Code blocks uses the same type of blocks as you would see in Scratch. Only the output in code blocks is a 3D design that you could 3D print, or you could even share as a GIF as well. So code blocks is super fun. Another thing I just wanted to let educators know is that Tinkercad is fully integrated with Google as well. So you can use Tinkercad with Google Classroom. We've also been included in Google's new Chromebook App Hub, which is a place where you can find not only apps that are recommended by the network of Google educators, but also inspiration, so lesson plans and different project ideas for the different apps that are included in the App Hub. So just really quickly, so one way that you can use Tinkercad is to encourage your students to be innovative designers. So here is an example from a school, the Brookwood School in Manchester by the Sea in Massachusetts. And at the Brookwood School, they have this really cool problem bank where people from the community, so teachers or even some of the elders that they work with, there's a senior citizens home that they work with as well, students can submit problems to this problem bank so that students can think of ways that they can solve these problems using 3D design. So some of these designs are actually printed as well. So here's an example. This was actually a first grader at the Brookwood School, and he has limb difference. And one of the problems that they were trying to solve is so that he can be involved more equitably in classroom activities. So students they actually had a 3D scan of his limb, and they created all different types of prosthetics and adaptations to the prosthetics in order to include him more in classroom activities. Another example, so you could also use Tinkercad to help your students be knowledge constructors. So here's another example. This is out of Boston and Cambridge, actually Bajika, which is a design studio in Boston, and New View, which is a student design studio in Cambridge, joined forces on this really cool civics in action project in which students identified different heroes from different neighborhoods throughout Boston and Cambridge. And then they crafted these really interesting fictional stories about their superpowers. So for example, this was a woman from Jamaica Plain in Boston who is a butterfly specialist. And they created this story in which she's a superhero. It actually was aligned with one of the Avengers films that was coming out at the time. So they created these butterfly wings that fluttered every time she experienced a microaggression. So there was also fictional narrative and speculative design that was happening through this project as well. So using Tinkercad invites all types of learners into the design process, and the input, is, oftentimes digital, but the output could also be multimedia as well. So this is just a cool design made by a 12-year-old, actually in Michigan, who is really interested in using like hands-on crafting materials, but wanted to create a waterfall. So she worked both in Tinkercad and with other media to create this cool water fountain. This is just an example of what code blocks looks like. So you can use Tinkercad also to do computational design and to help your students take their computational thinking and make it visible through creating code that you can touch. This is another example of a teacher out in California. He's a middle school teacher, and he has all types of awesome resources on his website, robmoral.com, but he teaches complex mathematical concepts using Tinkercad code blocks. And then his students are able to fabricate them. Here he's using a laser cutter, but he also even uses like a die cut machine, like a Cricut, for example, where students can make iron-on designs that are really complex two-dimensional shapes. Another way that you can use Tinkercad in your classroom to support students is through their creative communication. So I personally, as a parent, appreciate project-based learning, but I end up with a lot of like cardboard and poster boards and things in my house. So actually the geometry city on the right was created by my daughter last year in 4th grade. So this is a common project that elementary school teachers do and oftentimes involves cardboard. And we actually did it digitally in Tinkercad, but you can see how students can even express their spatial thinking and their spatial awareness through using Tinkercad and creating digital expressions of their learning. And this is just a really cool project I wanted to share. This is another speculative design project. This was also a project by Bajika, which is Nisha McCrae's design studio in Boston. And her students actually last summer worked in collaboration with NASA on speculative design. So the students were designing not just for now, but for like what if and for the future. So this was an example of a ring that a student designed that the ring connected somehow to, it was like an IoT device that connected to contact lenses. And she based this actually on a NASA patent. And really the most important thing I wanted to share was her response to doing this project, where she said that I like that we are able to design what we want. I like to do art and design. It's the career pathway I want. I want to be an animator or a fashion designer. So prior to being introduced to Tinkercad and this design process, this was not really something that she thought she could do for a career, but now she's really interested in pursuing that pathway. And this is Nisha, her teacher. She said the power of Tinkercad lies in how simply a student can create a CAD model that allows for them to quickly and easily communicate their ideas with their peers. When we use Tinkercad, we democratize our classroom and allow innovative solutions to rise. So just really quickly before we move on to Natrice's presentation, I just wanted to share that recently I actually came in contact with not one, but two teachers who teach both math and art. And this was fascinating to me in many ways. And I thought, what beautiful minds to be able to teach both subjects and to do it well. So I asked these teachers, so one question I asked them is, how are math and art connected? So thinking about putting the A in STEAM, and math is, oftentimes, sometimes the hardest subject to integrate with other subjects, particularly art. So this is Sedelia Chavez. She's an art and math instructor. She works in Albuquerque, New Mexico. And one of the things that she talked about was symmetry and how symmetry is a cross-cutting concept in both math and in art. So in art, you're dealing with all different types of symmetry. But she was really talking about how just in general, the balance that both math and art rely upon is something that is common amongst both subjects as well. She even says that when a mathematician gets an answer wrong, they feel it in their soul. So just talking about the balance there. I also asked her, what led you to be able to understand this connection between math and art? And she talked a little bit, she actually started talking about geometry and also talked a little bit about calculus as well and contour curves. And she talked about also the connection between, when you're doing calculus and the study of a contour curve. She was saying that it could also be, it make you think of like a bird's wing or the ocean. So even thinking about that concept of biomimicry is something that's common in both art, so thinking about studying nature and creating products and creating artworks that are inspired by nature is also something that's common in math too. So another teacher that I talked to was Stephen Jones, and he's actually a teacher in Illinois. I was going to keep messing that up. So he's hopefully listening right now. And I asked Stephen, how do you help students make connections between math and art? So Stephen teaches computer science, but kind of similar to Natrice, doing it through the lens of art, and he does a lot of architectural projects with his students. So architecture is another, another study that kind of intersects math and art. So talking about, organic shapes and geometric shapes and positive and negative space. So that was what he talked about. And then I just finally asked him, why is knowledge in both domains important for preparing students for the future? And he started to talk about generative design, which is a really cool concept that we can't get into right now in this webinar, but in generative design, you can collaborate with automation and machine learning in order to make products. And it definitely has an aesthetic as well, as you can see in the lamp that is featured here. So now I'm going to pass the mic over to Natrice, and Natrice is going to talk about her Math Talk project.
Sure. In this slide, actually, my current work is on the right, but on the left, I put this picture in. This is 1988, 87. My ceramics teacher I went to an art high school, or I went to a magnet high school that had an arts major and visual arts, and she decided one year to teach computer graphics. So my ceramics teacher taught me computer graphics. That got me into it and got me into college. So this is one of the first earliest pictures of me learning how to use the computer to make art. So now, in addition to working at the Fab Foundation, which has Fab Labs, which you can talk about, Math Talk is a early education company that transforms everyday public spaces like playgrounds, bus stops, and so on, into early learning environments. So we're working on a project called Mathscapes in Cambridge, Massachusetts, and in Boston, Massachusetts, which is a collaboration with both the cities and their respective school departments. And what we really were trying to do is kind of do these early prototypes where we put them in the space and figure out kind of where, what we can do to engage young people and families in math through art. So this was a professor in math art who worked on a two-dimensional treatment for a giant abacus, or a series of cases that's stacked. And this was just done as a two-dimensional idea at first. And then I came on board after this. So the idea was to put it either next to a bus stop or another in a playground. So this is some research that I've done in the past. I'm really interested in things like math and geometry, geometry and art. These are some examples of geometry and art. So at the top, you have a mural painting by John Biggers called The Quilting Party. And there's a lot of platonic solids, specifically, and quilt patterns in this painting. MC Escher was really into platonic solids, which I'll talk about in a second. In the middle are some examples of the actual solids as a sketch and the elements of in nature that they represent. And then on the far right is a game that I developed based on the painting at the top. So they're 3D printed platonic solids and game pieces, as well as a board to jump from circle to circle and answer questions about what you see in the painting. For those who don't know much about platonic solids, I want to say something really quickly about them. They come from the ancient Greek philosopher Plato, but they're thought to represent 5 basic elements: earth, air, fire, water, and the universe. So the cube is associated with earth, and octahedron is air, tetrahedron is fire, the icosahedron is water, and the dodecahedron is the universe. So when I came up with my idea is to take the initial proposal and bring it into 3 dimensions using Tinkercad. So on the left, you can see the model as I conceived of it in Tinkercad. And on the right is the actual prototype based on that model done here at Autodesk Technology Center, where I began to use some of the equipment that I didn't have access anywhere else. So this is actually in a playground in the back of an elementary school in Cambridge, Massachusetts. But you can see that the platonic solids are playing a role here, both in the beads of the abacus on the rows, as well as the cases themselves. I learned a lot of things here at Autodesk one of them is the base of the giant abacus was used a water jet, and you can see the top left is a water jet, which is basically cutting through stainless steel to create a very heavy base. There's welding, which we welded some parts of the giant abacus. And then there's a 6 foot, 5.5 to 6 foot printer here called the Big Rep, which we use to create the cases. And then you can see the kids interacting with the abacus cases in the playground on the lower right. So I did a little video of how I started, and basically you can see some of the models that I work with. We can just play. So when you're in Tinkercad, you can create a new file, a new document to work in. I started with the icosahedron from the shapes that are in the shapes area. And then I manipulated it by sizing it up. I'm going to eventually cut or slice into the shape by using something called a hole, which is basically another shape that intersects and then cuts away material from the shape. So one thing I want to do is inspect it. I'm trying to get it to be on a flat surface, so it's not just standing on the point, because when I eventually 3D print this, we can't start with a point, we have to start with a flat surface. So I'm really just kind of playing around with rotation. I'm playing around with, so the angles, so we talk about math. We can talk about rotation, translation, reflection, things like that we find in geometry. And once I get orientation of the shape that I want, I can then create another shape that becomes the whole, which you'll see in a second. So really it's just kind of on the picture plane, kind of what we would do in a ceramics class with a slab roller, where we're doing slab construction, where we're trying to imagine on the picture plane how a three-dimensional object would be oriented, and then manipulating materials until we get, using different tools, until we get what we want to have, and then we can use a kiln to fire it as opposed to a 3D printer. So this is me just trying to move around the picture plane to make sure everything's covered that needs to be covered before I make I group them both. And when I group them, and you'll see that in a second, it will slice away part of the icosahedron so that I have what will become a case similar to what I did for the Math Talk giant abacus. And then you see it's just by doing that function, you can see that I now sliced it, and then I can hollow it out. But for time, we can stop and move on. So we're on part 2, which means we put the prototype out in the playground, and there's some things happening that we want to be able to fix. So in this next one, we want to make it so that people, if they don't have 3D printers, they can flatten out all the shapes and then use a laser cutter and then assemble it just by folding the different shapes. So the new case is on the left, and then you can see the folded out version of it. And for that, I'm using another Autodesk tool, which is called Fusion 360 Slicer, or Slicer for Fusion 360. I'm not actually using Fusion 360, I'm using Slicer, which used to be 123 Make, something like that. And so I'm using that to take all those different surfaces, flatten them out, and then it can be assembled in cardboard or whatever material that people have access to, as opposed to having a large 3D printer. So this is the next iteration of the Abacus project.
And now we are ready for questions. That was amazing, Natrice.
Hi, Kayla. I'm with Autodesk as well. So for questions, we had someone asked if we could share more about how they created the cool butterfly project.
So it was interesting, so that I got to see the whole process in which they started even with cardboard prototyping. And then they also had done, like they'd done circuitry, because it was actually like, it actually like fluttered, and it was, electronic wearable device. And they also, I feel like, what do you think it was made of? It was 3D, was it 3D printed?
It looks like it's a laser cut.
Yeah.
From different pieces that were assembled.
They use a lot of Fusion at NewView as well, because they teach primarily high school students. So Fusion 360, which Natrice also talked about, is free for educators and students as well. But in terms of the technical aspects, I don't know tons in terms of how they integrated everything together. But I do know that it was a process in terms of interviewing people, writing narratives. And actually, if you go to, we did a webinar with them. If you go to Tinkercad teachers webinars, we actually did a whole webinar on the circuits environment on Tinkercad too, where we talk about it. Did I answer the question, Keela?
Yes, you did. Thank you so much. Our next question is from Stephanie, and she asks, how can this best be used for first grade?
I think probably what needs to happen is, I actually like the idea of assembling, making it flat and letting people assemble it. Even you can go in from Tinkercad to like Slicer and then giving handouts to students and having them use scissors to cut the pieces out and then try to recreate it. I think it gives them a real good, in terms of their skills of learning how to go from 2 dimensions to 3 dimensions, which is really something that happens in Tinkercad, but can also happen with cardboard or cardstock and scissors for the younger students.
Terrific. One actual other suggestion too is we do also have some kind of blocks available in Tinkercad that the students can then grab and kind of build like a playground or something else using kind of virtual blocks is another option as well. We're getting a lot of questions around getting started with lesson plans. So I'm going to put something in the chat, but I'll let Kellyanne talk more to you what kind of lesson plans that we have available.
So if you go to Tinkercad Teach, there's actually a whole section on lessons. It actually takes you to Instructables, the Tinkercad for Education Instructables page. Instructables is also part of the Autodesk family, and it's a really awesome site for step-by-step instructions for anything from making cookies to like building a shed. But we publish lessons through Instructables, so we have lessons on science, so about like how to teach about coral reef bleaching through 3D design and also like thinking about like 3D scanning technologies. We have, teaching math through Tinkercad. So we have a lesson on ratios. We've done pretty much like a lot of the different subjects. We also have code blocks lessons too, or 2 hour of code lessons on, one was on patterns and another was on designing with algorithms. So there's a variety of lessons, and we tried to cover a lot of the disciplines as well in those lessons too.
Perfect. Thank you. And then the next question is, do you have directions for the board game?
I do. It was my prototype that you saw. We played that in the STEAM lab. Boston Arts Academy, where I 3D printed the pieces, or I worked with students to 3D print them. But yes, it's a card game, it's a board game basically, and it can be played anywhere, I guess. But yeah, we definitely use Tinkercad to create the shapes and the game pieces.
Terrific, thank you. Just gonna answer this one. Someone was asking about microbit, and the answer is we don't have plans right now. We do Arduino within the Tinkercad circuit environment. Any other questions out there?
Well, we've also put out in this slide, you can see this slide right now. So we have just, if you come up with questions later on and you want some help with Tinkercad, there's the Tinkercad forum, there's the Tinkercad Help Center. We're also really responsive on Facebook and Twitter. We also have a Tinkercad Instagram, and we're on Pinterest too, Keela, right?
We are.
So we're very responsive, not just from Autodesk, but also just kind of the whole Tinkercad community.
We have another good question here from Byron. So Byron says, I've been working with 5th graders for several years. I try to encourage them to create original sculptural designs that we later 3D print. They tend to grab designs from Tinkercad, the Tinkercad community, and claim them as their own. Do you have any ideas to discourage them from doing this?
I think we're kind of in this, like, we think about open source world. I think the idea of remixing things or taking something but making them at something entirely new is a contemporary art practice. And I think that if long as the end at the ending is their own original creation, where they got their original source material is kind of open, but to make sure that they're not just copying or assimilating what they found, but they're making it something new, I think is the goal. So they can build on it, but it can't be the actual thing that they grabbed.
That's a great answer. Thank you. There was a question that I did answer in chat earlier, but I think it might be helpful to talk with everyone about. So they asked about resources to encourage the creative side of Tinkercad. They're an art teacher and want to push as much creativity as possible.
Is that a question?
So the question?
The question is, are there any resources to encourage, like what would you recommend to really get kids being creative around Tinkercad?
One thing that I'm actually working on right now that we're going to be putting out on the Tinkercad for Education Instructables page soon is a series of design challenges. I really think that providing students with like constraints is always something that promotes creativity, and also just like a fun sort of competition as well. So like some sort of like a design challenge that is also maybe draws upon something like issues that students care about, like climate change or like inclusivity or like affordable housing. So really kind of connecting what you're teaching to issues that kids really care about, and provide. And I also just think the importance of like constraints as well really kind of fosters creativity too.
And I know we're at the end, but I'll say, I mentioned before, I do feel like the Tinkercad environment reminds me of my ceramics class and the kinds of tasks that the teacher would have us do in clay. We found some of those challenges, and it's just a different tool, but some of the same spatial issues and some of the things that you would have to do to construct things is very similar to what would happen if you were using clay. So there is a kind of, I think, correlation between the two that could be made to really help students begin thinking about how they might do that virtually.
Terrific. We do have one more question if we have time. So the final question is, how would you suggest a science or social studies teacher apply these ideas into their curriculum?
Yeah, in the platonic solids image, for example, more on the social studies side, I had the John Biggers painting there. There's a whole bunch of historical information and cultural information in that mural alone that's even in the board game. And I think by finding artworks that have that kind of connection to either science or social studies, using that as a basis for developing new projects, so existing works that are out in the world, paintings, sculptures, and so on, I think is a good, in terms of inquiry-based, project-based is a good model to do and use. And a method in applying those in a Tinkercad in a virtual space is also interesting, and see what students will come up with.
We also have on the Tinkercad for Education Instructables page, we have a lesson on creating 3D population maps with students. So that's kind of like an easy for, you can have really complex content that you're teaching, but it's a really easy lift in terms of using Tinkercad as well. And then also the Coral Reefs Instructable has been really popular too for science teachers. So that's another one to check out as well.